my friends. Welcome to Origins. My name's Don Chapman. It's such a privilege to have you with us. You know, Origins is a forum where we take the evidence of science, we use it to validate the truth of creation. And we have a great guest with us today, one of my very favorite guests, Dr. Andrew Snelling. So
Thanks,
good to
Don.
have you with us, Andrew.
It's a pleasure.
Dr. Snelling is an Australian, has his PhD from the University of Sydney, and he is the Director of Research at Answers in Genesis. And today, as Dr. Snelling comes to join us, we're looking at geological evidences for the worldwide flood. And today, what are we going to talk about, Dr. Snelling?
Well, we first of all want to just review some terms.
Okay.
Many people need to understand what we mean by the word catastrophism. For example, if we're talking about Noah's flood, it had to be a catastrophic global event. And so catastrophism, as many geologists understand it, is where there have been short, violent events on the Earth, sometimes on a global scale. But the ruling viewpoint amongst geologists for many years has been the view called uniformitarianism. That's a big, long word, but what it basically means is a belief in the uniformity of natural processes, that only the geological processes that we observe today can be used to explain what happened in the past. And so there's a difference between these two views that's a time equation. If things went slowly and gradually as they do today, then that view requires a lot of time. Right. Whereas catastrophism is very short, sharp, violent events, and they can be extended to a global scale and with no time, virtually no time at all needed. And that's exactly what we would envisage for the global flood in Noah's day, because the Bible tells us that it was only a year-long event.
Wow, so just in that, there was a very different world before the flood and after the flood.
Exactly.
And one event changed the face of the earth.
Yes, yes.
All right.
Now, what we want to look at today in this program is the evidence that there was rapid or no erosion between the rock layers. Now, why do we want to do that? Well, you see, if the geologists accept that some of the rock layers form catastrophically, then what they want to do is have millions of years between the rock layers. Okay, and that's how they can still have the millions of years, the old Earth view. But from the biblical time scale, it's a young Earth. All the evidence for catastrophism can be compacted into the flood, and that means the rock layers were laid down one after the other without millions of years in between. So what we want to explore is, what is the evidence for time between the rock layers? Is there evidence for long periods of time between the rock layers, or is there evidence that there was no time between the rock layers, that they formed one after the other? So the evidence we're looking for is where there was either rapid erosion or whether there were flat, featureless, knife-edge boundaries. What I mean by that is you go from mud to sand and a knife edge.
Sharp distinction.
Absolute sharp, distinct boundaries.
Yes. Okay.
So let me go up here and show you
Show us
on
what
the
you got,
screen
my friend.
some of these evidences. Just to recap, the Tapete sandstone, it's right down here at the bottom of the Grand Canyon, this one here, okay? And this is what I'm talking about. See these rock layers here are at an angle?
Right.
Okay? And so the water currents came in like this and eroded off that surface.
So
okay?
everything below the Tapete is what was there before the flood.
Exactly,
Okay.
exactly. And so we envisage here the ocean waters rising up over the continents, and they come across and they erode off the previous land surface and leave behind that sandstone.
Okay.
So let's have a look at what it looks like in real life. Here we can see that flat surface, okay?
Uh-huh.
Okay, there's that flat surface. There's the rock layers below here. And notice also we can see some evidence of boulders here. I'm going to show you another view in a moment. Okay. But look at these layers of sand up here.
Straight across.
Okay? These are actually called storm beds. Why? Because if we look at the way these sorts of beds are formed in the present world, because we can make observations in the present world and relate it to the past, we find similar beds of sand form as a result of hurricanes on the east coast of the US.
Another catastrophe.
So, you know, one hurricane will deposit a bed of sand, you know, a foot thick or a foot or more thick,
sure,
in just within hours.
Right.
And so what this shows us that there must have been hurricane velocity storms at the time the ocean water swept onto the continents and picked up boulders eroded from down here and incorporated in the sand up here, and then you had these storm beds on top. So let's now focus in a little bit closer at some of these boulders so you can see the scale. Here's a man's hand, and you see this big boulder here? Okay, here's the storm beds up here. This is the Tapete sandstone here, and down here is this erosion surface down here, okay?
Okay.
Now, in some places, these boulders have been found to be the size of cars and houses.
Sure.
Enormous. Now, you can imagine how fast the waters were flowing to pick up boulders the size of houses, and that sort of water would have ground down everything below that. Now, that's the sort of evidence we'd expect with the onset of the floodwaters, the breaking open of the Earth's crust, the rain falling from the sky as the Bible describes, and the water starting to sweep up from the oceans with hurricane velocity, earth movements causing tsunamis, and sweeping up, picking up these large boulders and grinding its way across the continental surface to then deposit these sands. So that's the sort of evidence we'd expect to find for Noah's flood. Now, we've looked at the Tapete sandstone. We now look at another situation where the underlying rock layers have been rapidly eroded, but only locally. Okay? And I want to look at this at the base of another limestone called the Temple Butte limestone. And we'll just review where that is in the Grand Canyon sequence so we can get oriented in the cliffs, the walls of the Grand Canyon, so we can see where we're looking at. Okay, the Temple Butte limestone is the one that we're referring to. Here's the Red Wall limestone, okay? Here's the Red Wall limestone cliff. Below that is another limestone called the Temple Butte. Okay, in places it forms just in erosion channels. I just want to point out another limestone. Below that is yet another limestone, this one here called the Muave limestone. Okay, so there's 3 limestones in a row. Now in the next photograph, we'll actually see it in real life in the field. Here's the Red Wall limestone here. Here's the boundary. We've already got it marked on the screen there.
Really clear.
Here's the Muave limestone. Okay, this one is supposed to be 500 odd million years. This one here is about 350 million years. And this one here is about 380 million years in terms of the conventional thinking. But this Temple Butte limestone actually forms in a local erosion channel. So in other words, here we have evidence of rapid erosion where channelized flow carved out this limestone. Now the reason why I've put these ages up there is because in some places in the Grand Canyon, these 2 limestones here look as though they were deposited one after the other. There's no evidence of any erosion in here. They look as if they merge into one another. In other words, there's not 150 million years worth of erosion between them. The only place where we see erosion is these localised channels, like here with the Temple Butte, and yet look at the time difference supposedly between them. For localised erosion, you wouldn't have, that huge amount of time between them, 120 million years. So in other words, we've got a rapid sequence of events, almost continuous erosion between these 2 limestones and localised erosion rapidly for this channel flow here. Well, let's make it a little bit easier with this next example. This is fairly easy to understand. Here we're going to look at the base of the Coconino sandstone, okay, where we can see a flat, featureless knife edge boundary that indicates continuous deposition. Okay, there was no erosion because everything just was continuous. Let me unpack this for you so you can understand. Okay, here's the Coconino sandstone up here.
Okay.
Down below here is a shale, and you can see it's red-brown. Look at this knife edge boundary. It's right really along there. It's very clear.
One thing happened, the other thing immediately
went on top. You go from the red down here to the white up there.
Yeah.
Okay, now the geologists say that boundary represents 10 million years of missing time. So wouldn't you normally have expected to see a topography?
Sure.
Okay, but it's not there. It's flat, totally flat. What that implies is that there 10 million years never happened.
There's no time between the 2.
You had deposition of this mud, because this was mud down here, and then you had deposition of this sand immediately after it. that was continuous deposition with no time break in between. So with just that boundary there, you've wiped out 10 million years of geologic time. Well, let's move on to the next amount of evidence we want to talk about, rapid succession of rock layers. Okay, in a sense we've already touched on that. Because there's no erosion between the rock layers, then they were formed in rapid succession. But I want to show you now a very interesting piece of evidence. It's fairly easy to understand if I explain it to you carefully. We're talking about the folding or bending of whole sequences of rock layers without fracturing. You know, have you ever tried to bend a piece of rock?
Doesn't happen.
Doesn't happen. You know, put it on your knee, what happens? It doesn't sort of bend nicely, it breaks, it fractures. But if you were to take a piece of pottery, like a piece of rock, and try to break the pottery, what happens? It snaps.
Yeah.
But the clay from which the pottery is baked is soft.
Right. Then
Okay?
it bends.
And it's pliable. Okay? So, in what state would a rock have to be if you're going to bend it without fracturing?
It would have to be almost pre-rock, like it was the material the rock was made
exactly,
of. Exactly.
Before the cement had hardened to bind the sand grains together. And when do you think that might be? When the rock is still soft.
Just there, right.
Yeah, just after it being deposited.
Right.
Okay? Well, here we can see at the bottom of the Grand Canyon, we've already met the Tapete sandstone many times, and we know that sand that's turned to stone, okay, when it was still sand, it was soft, but soon it became stone, it was hard. Now look at these folds, the bending of the rock. You can trace the layer. See, it comes through here, and then it goes through 90 degrees, a right angle. See the people down here for scale?
Wow.
Okay, and notice you can't see any major fracturing.
So that had to have happened, those bends had to happen before it was rock, when it was just sand.
When it was still soft sand. Yes. Now that would have been very soon after it was deposited, when it was still wet, because when the sand dries out, the water dries out, the chemicals in the water form the cement that bind all the sand grains together.
How long after it dries does it go from sand to sandstone?
Well, it can happen very, very rapidly. We make artificial rock by taking cement. As long as it's wet, it's not bound together, but as soon as it dries out, it's rock hard. And so that's what we can imagine for this sandstone.
Okay.
Here's a close-up view, so you can get to see. Here's these layers. See how you can see, you can trace them. There's very little fracturing. This is the same Tapete sandstone, okay? So a close view shows us that there isn't that fracturing. Now, here's the difficulty for our slow and gradual geological friends. Here's the Tapete sandstone at the bottom of the Grand Canyon. It's over 500 million years old, and here, of course, is the bending that we've just seen in those photographs. But all the other rock layers above are also folded in the same way without fracturing.
Yes.
Now, the topmost rock unit in the Grand Canyon is the Kaibab limestone, and it's 250 million years old, okay?
So that's 300 million years.
So you've got 300 million years during which this rock layer sequence is deposited before this bending occurred, okay? But the picture even gets worse. Here's one of the limestones, okay? The Muave limestone folded here, and you can see the person for scale. And you can see it up here in the Redwall limestone. They've all been folded without fracturing. Okay, and this is supposed to have been, these rock layers are supposed to have been formed over a 350 million year period. So let's put together the information here, the folding of the Tapete sandstone. Okay, we begin with the Tapete sandstone folded about 550 million years ago. Okay, let's work through this so you get the obvious conclusion. We form the other rock layers above until we get to the Kaibab limestone 250 million years ago. So over 300 million years, as you've already noticed, we've got these layers formed. But the interesting thing is the plateau that was responsible for the folding, this upwarp, where they pushed up the plateau, occurred 70 million years ago, which is, okay, 480 million years after the Tapete sandstone was deposited. Yet the irony is that, okay, the Teach sandstone is folded as though it was still soft from just being deposited 480 million years earlier. I mean, you can see how ridiculous the long ages view is, because obviously the Teach sandstone has been folded while it was still soft. It hadn't been enough time for it to dry. I mean, after 480 million years, it would be rock hard.
Right.
And so that tells us that this whole succession of rock layers, from the Teach sandstone all the way up to the Kaibab limestone, was formed in the first few months of the flood. Then, at the end of the flood, you had the plateau country pushed up. The rock layers were still wet from being saturated with the flood waters, but as soon as the flood waters retreat, the folding has taken place while it's still soft as the plateau goes up, and then as the floodwaters finish retreating, everything dries out and the cement makes them rock hard, cementing them in that folded position. So with just this one example, we've wiped out hundreds of millions of years of so-called geological time, and this whole strata sequence in the Grand Canyon that's supposed to have taken 500 million years to form has taken place in a few months, consistent with the biblical account of the flood.
Thank you for sharing that with us. It's absolutely astounding, and it's exciting me too. Don't go away, and don't you go away. We'll be right back, and we have more good stuff for you. You want to be here.
Creation versus evolution. You weigh the evidence. A global flood, evidence pours in. 20th century geologists taught the familiar maxim, the present is the key to the past. But now that catastrophic processes are widely used to describe the strata record, 21st century geologists are discovering that marine flood sedimentation is the key to the past. Geological strata and their marine fossils provide critical evidence that the oceans once covered the entire planet. Widespread strata blankets are leading geologists to construct a global flood model for Earth history. Today's guest on Origins, geologist Dr. Andrew Snelling, is the Director of Research at Answers in Genesis. He's been very involved in technical research, creationist publications, and is the author of Earth's Catastrophic Past, Volumes 1 and 2. Book orders are being taken at 800-778-3390. Andrew has traveled around the world speaking on the overwhelming scientific evidence consistent with the biblical account of creation and Noah's flood. Dr. Snelling has also been involved with the RATE project, which has produced breakthroughs on the subject of radiometric dating. Dr. Snelling can be reached at Answers in Genesis, P.O. Box 510, Hebron, Kentucky 41048, or visit the website www.answersingenesis.org.
We're back with Dr. Andrew Snelling. We're looking at evidence for the flood. And all I got to say, Dr. Snelling, is wow. What you've just presented to us about the laying down of the strata is absolutely fascinating and irrefutable. But what else you got for us?
We've just talked about the folding of whole rock layer sequences. Yes. Now, what we want to talk is about polystrate fossils. What do we mean by polystrate? Well, straight comes from the word strata. Poly means many. So, in plain English, these are fossils which required more than one rock layer to bury them. So let me go up to the screen and show you what I have for you. Let's look at this next photograph. Okay, on the left we can see over here the real life view. Here's a cartoon that helps us to follow. The place is Newcastle in Australia. It's north of Sydney, and here we can see down the bottom is a coal bed. Okay, that's coal, okay. C-O-A-L. And up here we can see another coal bed, okay? And of course it's mentioned in this cartoon. We can see sitting on the coal bed, we can see here a fossil tree, and we can see another one here, up the top there. Okay, can you see that one up there?
I can.
And you can see another one here.
Right.
These are volcanic beds in between,
all
okay?
Right.
Now when some of these trees were discovered, they went all the way from the bottom coal seam right through the top coal seam. So keep that in mind, because you see the geologists say that the coal took thousands of years to form in a swamp.
Yes.
But these trees are a type of pine tree that doesn't grow in swamp. So that makes a problem for the swamp theory. Secondly, these trees don't have roots on them. So how could they have grown there?
So they're logs, not trees.
That's right, they're logs. So if this was a long period of time, you'd have thousands of years for the first swamp, then you'd have the tree buried there with this volcanic ash coming in, okay, and there seems to be evidence of at least 4 eruptions that would have buried these trees, but then you had to have thousands of years more up here for this next swamp, remembering that these are trees that rot in swamps.
Sure.
So what does that tell you? It means the thousands of years never happened, that this vegetation was washed in rapidly, the tree was trapped, the tree stump was ripped up and buried rapidly with this volcanic ash, and more material went up on top.
That it happened quickly.
Exactly, and so we call this a polystrate fossil. It took many layers to bury these fossil trees. Now, this is not the only place in the world where we see this. If we go to another part of the world called Joggins in Nova Scotia, it's on the eastern coast of Canada.
Right.
And at this place you can see these fossil trees. Okay, there's the tree there. You can see the pattern on of the bark. Here's another one of these trees.
Right.
And you can see the sediment layers are like this.
On both sides.
On both sides, okay. And you can see that it took lots of layers successively to bury these trees. And again, these are tree stumps that would have rotted very quickly. So it means that all the rock layers had to have been coming in quickly, all the sand and mud, to quickly bury these trees. And so when we sum it all up, we're talking about 2,500 feet of rock layers through 20 geological horizons, or 760 metres of rock layers, had to have been deposited within months before all those trees would have rotted. So again, polystrate fossils, many rock layers burying these fossils, indicate that there was a rapid succession, very short time scale for thousands of feet of rock layers to form. So I'm sure you find that's almost as good as the last example I gave you.
Two tremendous examples indeed that we have in this lesson. And again, how does the other side refute that? I mean, it seems to me that there's no other explanation of how these trees could be through multiple strata other than the fact that the strata were laid quickly.
Yeah, by and large, they ignore those fossils.
Those aren't there, huh?
Well, they're there, but they don't describe them. The ones in Australia, for example, have been ignored for many, many years and are not talked about by the geological community, because they're obvious evidence of catastrophic sedimentation. The reason this is not just a scientific argument is because it has spiritual implications. It's not just about the here and now, it's about eternity. Because you see, if the Bible is true about the global flood, then the warnings we read in the Bible about the coming judgment by fire are real.
Yes.
And it means that just as God provided Noah, the ark, as a way of escaping from the floodwaters, God has indicated in the Bible that there's an ark of salvation, Jesus Christ, that if we put our faith and trust in Him, we'll escape from the fiery judgment to come.
Jesus is our ark, isn't He?
Exactly, and that's why if we can believe Genesis chapters 1 to 11, then we can believe John 3:16.
Dr. Snelling, I'm so thankful that you're my brother in Christ.
Don.
And it's been great having you here. And I am so thankful that God has given to His church a precious gift of someone with your keen mind to look at the evidence of science and validate through the rocks the truth of God's creation.
Thanks, Don. It's all about God.
It is all about God and what He's done, and that we can believe His Word, and what it's said about the past tells us we can believe Him for the future. Remember this, my friend, until we meet here again on Origins next time. It's God's view that He created you, and that should be your worldview too, my friend. God bless you till next time.
Thank you for watching this edition of Origins. If you'd like a copy of the PowerPoint information presented today, you can download a PDF file of program number 907 from our website at www.originstv.org. Or for a DVD of this series, send a $12 donation to cover shipping and handling and write to Origins, program number 907, Cornerstone Television, Wall, Pennsylvania 15148.
Origins is made possible by the faithful prayers and the financial support of you, our Cornerstone Television family.